Good evening. For tomorrow's investigation, we're going to do one of my absolute favorite investigations in this book. And here's why it's my favorite. And it's totally a math teacher reason. Because, well, this is a really common high stakes 8th grade question. What I mean by high stakes is I've seen it show up on CSAP, back when it was called CSAP. I've seen it showing up on TCAP. I've seen it shown up on PARC. Now, I haven't seen it on CMAS yet, but doesn't mean there isn't time. May have been last year, may show up this year. So, let's take a look at this. The big goal for today is we are going to figure out how we can predict if a pattern between variables is linear or nonlinear for a change. Third day in a row. Well, first day, bridges, thickness and strength, it was linear. Second day, we had bridge length and bridge strength. It wasn't linear, it was inverse. Well, let's see what today is going to produce for us. All right, so remember, we're going to do the investigation together as a class, but I'm just getting you ready for it. You can do the notes, get ready, understand what's going on so we can go right into the math. All right, so here's the deal. We are working for a construction company, and we're going to call that construction company, I don't know. How about, I think it's called CSP, I'm sorry, CSP. VSP is my vision insurance company. But I have LASIK, so my eyes are really, really good, but not everyone in my family is that way. So, we are going to be making two types of architectural or engineering products. We are going to be making these beams. Now this beam really looks like a truss. And a truss is simply a beam that is created by taking smaller pieces, putting them together to create a longer piece. And I used to be an architect, actually that is true. The deeper the beam, or the deeper the truss, the stronger. And so the advantage to this style of beam is it's a lot lighter, it's a lot cheaper, and it's a lot stronger than if you had one solid I-beam, one solid piece of steel. So we have this truss, they're going to call it beams, and I believe they call this it's a truss, they call it a truss. And the way it's put together is you have these 1-foot metal rods that have a fastener piece at the corner of each one right there. So we are going to describe these beams based on their bottom length. So this is a 1-foot, rod. And so how many rods does it take to make a 1-foot truss beam? Well, oh, look, there's a paperclip 1-foot truss beam right here. Well, how many rods did it take? Well, we have 1, 2, 3 rods. So, do you guys smell that? I smell it again, don't I? Don't you? I mean, I do. It's obvious. We need a table. I smell a table. It's coming right down the road. All right. So, oh, look, a table. All right. So, we don't have 1, but I don't like this table so much because it starts here with 2. So I'm going to make a slightly different table, and I'm going to do that right over here. All right, so if we have our length and the number of rods, and the length of 1, I'm going to leave a blank. It's a common theme. I'm always leaving the top blank, aren't I? So if we have a beam or a truss that is 1 foot long, we have 3 rods. Well, let's see what happens if I have 2 feet. So let's go back to my paper clips. All right. So that's 4, 5, 6, and we have to tie the top together, 7. So, and all my paper clips are the same size, so that's why it's a little bit off, but we'll get through together. So now we have 7 rods for a beam that is 2 feet long. Let's go back to the table. All right, so 2, and we have 7 rods. Well, having 2 entries in a table, that is just not enough to create a pattern. We need a third. So let's go back to the paper clips, shall we? All right, so we need 1 more rod on the bottom. So that gives us our 3 feet. So we had 7, that's 8, that's 9, that's 10, that's one of the long ones. And now we have to tie it together, so that is 11. So when we have a beam that's 3 feet long, we have 11 rods that are tied together. Let's put that in our table. All right, so we have 3 feet long, and that's going to be 11 rods. All right, so that's what's happening with our, if I circle it, you can't see it. That's what's happening with our truss beam. So that is one of our products. Let's take a look at our second product. Now clearly you'll need your table for tomorrow's class, and having something like matchsticks, toothpicks, or paper clips will be helpful for understanding what happens next if you find that thing helpful. So if you would like to have that, go find it in your house. And I'm going to sneeze because my nose is, all right, maybe not. All right, so let's take a look at our second product. Our second product is a product called a stair-stepping truss. Now, no one in their right mind would ever make a building product like this. Triangles, muy fuerte. Rectangles, wimpy, wimpy, wimpy. So definitely not realistic, but we're gonna go and look at the math anyways. All right, so let's take a look at what's happening. All right, so I'm gonna take that away. So if I have a 1-foot staircase truss, I'm just making a little rectangle, right? Well, how many rods does that take? Cuatro. Actually, I can't speak Spanish to save my life. I took French. I wish I took Spanish, but I lived in France for a while, and I'll tell you, French is far more helpful if you live in France than Spanish. Okay, so I'm going to pull this table over, and we'll start the same way. Okay? So if I have 1, and I don't like that. I don't like this table. You'll see why later. So if I start at 1 foot, that's going to take 4 rods. All right, and so we have length and we have rods. Well, what happens when we have a second one? All right, so remember, this is a stair-stepping thing. So we have 1, we have our 4, 5, 6, but it's a stair step, so it goes up 7, 8, 9. So now when we have 2 feet, we have 9 total. No, let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my goodness. The one thing I've noticed about teaching algebra for so long, my algebra skills are fantastic. My counting skills, not so good. That's 10. All right, so now we have 2 feet and 10. Finally, let's do 3. So we need to build a stair of 3 here. So we have 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so I feel good about this one. So now we have 18. So let's go back up here. All right, so now we have 3 and 18. Now, if you can figure out what I'm going to put here, go for it. But please, please, whatever you do, don't just automatically put 0 here, because 0 should always be 0. That's not true. If anyone told you that, they should not teach you math. You've got to follow the pattern. Math is all about following patterns. If 0 doesn't keep the pattern, then you can't put it there. Even though you may think it makes sense in this context, it doesn't. It might, but not always. All right, so tomorrow we're going to be talking about truss beams and step beams, and we're going to see what kind of relationships we get when we extrapolate this beam something much, much larger. All right, enjoy your ACE because everyone enjoys homework, especially me. I love homework. Talk to you later. See you in the morning or afternoon. Either way, I'll see you tomorrow.